Okay, we have an interesting problem here, and let me get back to the actual, here's the problem. This is number 11 from 4.8 in Math 126 OE1, and it's asking for a regression analysis. Now this student did it, got it correct, but I was asked to do this problem. And I think it's worth doing and showing how it is found in Desmos. It's really not a bad process. So the table below gives the growth in the population of harbor seals in the Wadden Sea from 1997 to 2012. Of course, the data sets are off because it goes 95 to 2010, but I'll just ignore that. Calculate the logistics regression model for these data. Give all coefficients to 4 decimal places. Excuse me. So what I did is I started at 0 for the first year given, and then I went up from there. And this is the hardest part. This is literally the hardest part of doing this type of problem. Then I go into Desmos, and I do 0 for the first year and work my way up to the final year. And then I had to copy and paste each data point in. And so I didn't actually type it, I just copy, paste, copy, paste, copy, paste, copy, paste. And you don't need to see me doing that because that's rather boring to see. But the point is to get the data set in here. And whether you're doing it on a calculator or in Desmos, it's the same. It's going to be something you have to do. So that's going to be your hard part. So you get this nice data showing up here in the graph. So now you're going to go to another line, and notice up here we call this X1 and Y1. So X1 is the years, Y1 is the data for the year, or the number for the year. So the way we write this up, we just do Y1. I didn't do anything for the subscript. It automatically subscripted that. Then here's the big trick. On my keyboard, it's right next to the 1 button. If I hit Shift, I get the tilde. So it's saying Y1's approximately, then I'm going to say, I know it's a logistics growth model equation, so it's going to be something A divided by 1 plus B, 1 plus B, E, then I do my caret button, E to the C, X1. So I noted this X1 corresponding to this X1. So then it comes up, and you saw how quickly that came up. It's pretty amazing. And it comes up with our R squared value. I mean, that's real close. That 0.9984, that's a really good R value. But then 25.6567. So if I go back over to here, 25.6567, that was the number on top. Then I go back to here, and then I have 6.11369. So if I'm going to go to 4 places, that'd be 6.1137. And if I go back to the answer, it was 6.1137. E to the, and what was the other? I think it's this one here. Then what's my C? The coefficient for the X1 is negative 0.385215. When I go to 4 places, I just cut it off at 2. And let's just confirm that. That's what it was. So you see how quickly and easily, just to be fair, doing a regression calculation, even linear, is a lot of work and a lot of prone to error. And that's why we have these programs to do it. So the big point of this section, and really this chapter, is getting comfortable using these tools to analyze our data. And then we are able to take that skill that we've developed and apply it for other purposes. So hope that helps, and I will see you later.